So I'm trying out some more of these little electrolysis experiments, and I was having a problem where it was hard to film the tip of the electrode when the electrolysis was going, because the bubbles would start building up and it would obstruct the view of the electrode, and it was kind of hard to control how far the electrode that I wanted to be in pinched mode was submerged. The other electrode is easy because you can basically just submerge it as far as you want to ensure the pinch mode on the cathode, but the cathode depth control was a little tricky, and I realized I could solve both problems at the same time by basically using shrink wrap. So I coated the cathode with this clear shrink wrap that you would use on like a solder joint or something along those lines, and basically just covered the electrode enough to leave however much of the tip exposed that I wanted, and I measured it to about 3 millimeters, and then covered up the rest, which has two effects. It controls the length of exposed electrode without having to have a fixture that controls, the height up and down of how far you submerge it. Regardless of how far you submerge it, there's only a certain length of the electrode exposed in the electrolyte solution. And the other thing is you can now put it in farther, so that way the bubbles rise to the top very quickly and they keep the electrode reaction area clear of bubbles and doesn't obstruct the view. So here's kind of the 1 millimeter titanium one that I made, 1 millimeter diameter titanium electrode. And if I get this electrolyte off of here, like so, you can kind of see, well, it's hard to focus, but you can see the shielded part where the heat shrink is on. And I was thinking clear heat shrink would be good to use at first, so I can check if the electrolyte is creeping between the shrink wrap and the electrode, and I haven't seen any of that, so I'll probably just start using solid color shrink wrap, so it'll be really easy to see where the electrode is exposed and where it is not. But this turned out to work really well, and now you can get different shots of looking face on at the electrode and all kinds of different geometries, because it doesn't matter how it's submerged anymore. You're always keeping the 3 millimeter, the exposed electrode area is now constant, totally independent of how far you submerge the electrode or what geometry, what orientation you submerge it at, which is pretty great. And I've got some footage that I've gotten of some of these high voltage electrolysis reactions happening at different voltages, some different orientations of the electrode, which are pretty interesting. I also figured out a lot more about how to use this camera because I'm dumb, and at least with cameras and whatnot, I don't know too much about them, and so I've been playing around a lot with this thing and figured out how to put it in full manual mode for the high frame rate. filming so I can get the focus just right and all that good stuff. The titanium electrode straight up and down, essentially vertically in the electrolyte, and you can see how as the bubble builds from the electrolysis products, uh, as the gas evolves, it insulates the electrode, which in turn prevents the reaction from happening because the electrode is no longer in contact, except for in small parts with the water. And as soon as the bubble begins to break away and does break away, we see this, the reaction really take off again, and it restarts the process. Now this is at a sort of lower voltage, around 60 volts or so. And it's interesting because in this orientation specifically, uh, because of that insulating sheath on the electrode, it causes this bubble to sort of form and stabilize around the electrode, at least when filming at 960 FPS. This is obviously happening very quickly, but this dynamic behavior is pretty consistent at this 60 volt setting. Here's another example with a different orientation of viewing the electrode. I put in a bend at the end of the electrode, and so now we're looking at it face on. And you can see how the bubble uh, forms differently and breaks away in such a way that allows the face of the electrode to have a pretty continuous reaction happening without getting fully insulated from the electrolyte solution. Kind of a different pattern of operation here. Pretty neat shot, I think. And again, this is only really possible for me to do because of insulating the rest of the electrode with the shrink wrap. Here's a side-on view of the electrode, the titanium electrode, and this video you can really see the micro sparks quite well, and they're in focus. Yeah, but that's kind of what I've been playing around with some of these electrolysis experiments with the pinched electrode operation, specifically having the cathode be pinched. Um, yeah, this is pretty amazing that you can catch some of this sort of short-lived, fast behavior on camera relatively easily.